Hello, everyone. Yeah, it's working. Thanks for coming to this session. We will speak about the Linaro Automation Appliance, and we'll do a short preview of what it is and what we're expecting to do with it. So my name is Rémi Durafour. I'm a principal tech lead at Linaro. I'm managing and leading the software automation team. And with me we have...
I'm Sahej, and I'm just an engineer at Linaro. I've been working on the appliance for a good part of past year.
So the reason why we're speaking about Linaro Automation Appliance, it's because it's a nice project, but also because it's a foundation for another big project, which is OneLab. I guess you all heard about it during the keynote. So if you just really quickly look at the OneLab architecture, it's really simple technically. The architecture, it's like a front-end and back-end software. So you have the OneLab front-end that you've seen today with the different boards, different firmware and tests that are run. This is a front end. Behind there is obviously a back end with all the data, but that's not what I'm interested in today, because the back end of OneLab will have to run tests on boards, and for that we use Lava, obviously, because we're the one using Lava a lot. So we have a Lava instance which is dedicated to OneLab, and then you need to run the test on real hardware. And for that, we have classically remote labs that will be at customers' premises, and that will run tests on real devices. And each of the automation will have an automation appliance that will be used to automate the board, because we all know that automating board is not an easy process. So the first thing, I want to introduce a bit what Lava is, because it's maybe not obvious for everyone in the room. So Lava stands for Linaro Automation Validation Architecture. So it's a project that started 13 years ago, if I remember correctly. Looking at the Git log, it's been a long time. So the goal of Lava is to test software on real hardware. So we'll take your kernel DTB root file system and test it on real hardware. So Junos, Dragon Balls, iKeys, X15, things like that. So it will deploy, boot, and test your software on your hardware. It's using a lot by the LKFT project, Linux Kernel Functional Testing Project, for doing validation of the Linux kernel. It's used for doing bootloader or firmware test. For example, we can test U-boot with it. And it's obviously also used for system-level testing and firmware-level testing with OneLab. It's currently supporting 387 different device types, from IoT devices, dev boards, laptops, for example, Chromebooks, and even big servers. And for example, in Linaro, we have a lab at Cambridge with roughly 200, 250 boards, roughly. And there is many labs, different Lava labs in the world. So if you want to test without Lava, that will be painful, but you can do it manually. So this is a Raspberry Pi 3. That's a really old picture. You need a way to control the board power. So you need a way to, if I send a command to some hardware, it will power on or power off the board. You need to have a way to access to the serial. So Certnet will work for that, for example. So you power on the board, you connect to the serial, you wait for U-boot, you interrupt it by doing entering enter. You ask for an IP address, so DHCP, which means that you need to have a DHCP server on your network. You set the server IP, then you load the DTB, the kernel, RAM disk from TFTP, which means that you have to type the right addresses, the right commands in U-boot, and then you ask U-boot to boot your kernel, given the right addresses. You look at the kernel logs, looking for warnings, bugs, whoops, things like that. You log in, so root or something. You run your test. Again, you have to check that all the tests are passing. Maybe there is kernel warnings. And you collect all the results, and you power off the board. That's okay if you do that once a day, maybe. It's already boring. But if you do that a lot, that's just impossible. The goal of Lava is to replace all that human interaction by a software, which is Lava. So we have a Lava worker, which is a PC, for example, with some software installed on it. It has access to the same hardware that we were speaking before, so serial access, a way to control the power, a TFTP server, an NFS server, things like that. And you will give it a job definition, which is a YAML configuration, in which you explain all the previous steps that I explained before, but a bit abstract. So you will list the kernel, DTB, root file system. You will say that it's a U-boot-based board, and it will just boot it for you. And you list the test that you want to run, and Lava will test it for you. So all the previous steps will be done automatically for you. Obviously, Lava is based on a server and worker architecture, so you can have multiple DUTs, device under test, Raspberry Pi in our case, per worker, multiple DUT per worker, and multiple worker per infrastructure. The server is mainly the web interface with APIs, so it will store the logs, do the scheduling, it will do access control, so it can be anywhere in a cloud service. It will also do notifications, for example. And on the worker side, they will be responsible for deploying the resources, so they have to be physically attached to your DUT. They will power on, power off, parse the logs, and send that back to the server over the network. Just for fun, this is an actual list of device types that we support. It's ever-expanding list. It's just for fun. So on the software side, Lava is more or less a de facto standard now. It's used by a lot of people. It's considered to be, there is still a lot of things to improve, but it's considered to be a non-good solution. On the hardware side, which is how do I physically automate my DUT, it's still old, it's a bit complex, and it's still always custom solutions. Because there is always multiple solutions for every component that you need. You have to decide on which FTDI cable you use for serial access, on the power relay PDUs that you use, on the worker that you will have, your PC. You can have, yes, there is many options. So it's not easy. That's why we have the Linaro Automation Appliance. And I will show you a small, short demo of what we do with it. So it's right. Yeah, so I will show how we used to do things and what most people are still doing and what we are expecting to be able to do with the Linaro Automation Appliance. So on my setup, this is my Lava worker. So which means that on it, I have to install Debian. I need to have it has to be the DHCP server because I need to have a DHCP server on my network. I'm using TFTP, so it has to be a TFTP server. I'm using NFS, so it has to be an NFS server. I'm using HTTP for something, so it has to be an HTTP server. It has to have a serial relay installed on it. So a lot of things to manage just for the server. Then I have an FTDI cable connecting to my Raspberry Pi here. You see it? So you see it's connected to the header, which means that you have to know how to connect your FTDI cable to the header to have the right UART pins in the right order. If you don't do it correctly, it will just not work. And you need a way now to control the power. So for a Raspberry Pi, usually power is going through USB. So here is it's an Ethernet relay. So it has you cut the wires, USB wires. You take the VBus, which is a red cable. You put it in a relay, and then this board will be able to, you will be able to send some commands to it to put on and off the DUT. Which means that also that you need this board to have a fixed IP address because the worker will need to be able to connect to it. You need to create a script that will send the right commands to power on and off the board. And then you have to send all that configuration to Lava in the proper format. It's okay if you know how to do it, but it takes some time. That's the old setup. And all of the wires that you see, now they are replaced by only one board, what we call the Linaro Automation Appliance. So on it, you see that this is a network cable that I need, and then I have just a power cable. That's the two only cables that you need to have a Raspberry Pi working. Then I have an adaptation board. Saj will explain a bit more how it's working later on. And on top, I have my Raspberry Pi, which is just connected with one cable, which is a network cable on a specific network interface. So if you see on the screen, this is the IP address of the board on my local network. So Look. So I browsed to this network interface, to this IP address, and this is the software running on the appliance, because the appliance is a full Lava worker. It has everything you need, so it does embed a small website for configuring if you need to configure anything. So the first thing that you have to do is to register the appliance with the fleet management, because we have a fleet management software. So you just click register. It will go to lavacloud.io website that is the fleet management software. Come on, it is. You give it a name. Let's say LA01, for example. You register it, and you see that it's assigned automatically to a Lava instance, which is our staging instance. If you go into staging and you look for the LA01 worker, you refresh the page, and you see that it has been created automatically for you. So the configuring the worker, which is usually you have to create a worker in the database, keep the token, send it to your appliance. This is automatically done by the management software. You just have to click on register, assign it to an instance, and that's done. And if you look, it's already online. So technically, it's already online. The appliance is already running the right Lava software for connecting to the Lava instance. Going back to the fleet management software, we'll configure the device under test that we want to use. So this is a list of devices that we currently support. I have a Raspberry Pi 4B connected to it. I just click on it. And if you go back to Lava, you will see that I have now a device in my Lava setup, and it's already running something. This is running on my appliance right now. And if you wait some seconds for my appliance, to download, it's still downloading. So this is running on the appliance that you have here. It's downloading, it's just running an health check, and you will see that it should, you see the lights. It's actually on, so it's booting. And so in 3 minutes, maybe a bit more, I was able to have a DUT, a Raspberry Pi connected from scratch and running now a health check. And you can just run other jobs now if you want to. So, going back to the slides. So yeah, just again, you want to continue maybe? It's up to you now. Sorry.
All right, let's talk about hardware. So the idea of creating the appliance came from issues what we were having in our own lab. And what we were basically doing is we would take the the setup we have on our desk with like relays and loose FTDI cables and everything, and then just shove that into a rack on a server rack. And that wasn't very stable. We had relays failing, we had wires coming out loose, and there were just issues. So we wanted to make something that was standard and would support all the devices, but was also flexible. So what we came up was with a layered approach, like a cake. And so you have the standard interface board. That's the Lava worker that runs everything, and then we have a standard header on it, and that particular header is responsible for like powering the device on and off, talking to serial. It has a couple of USB ports on there, and then we ended up with a really, really nice USB hub that can be remotely turned on and off, even if the USB hub itself crashes, because some dots can do that. And then we have a separate network interface that goes through the worker, and that's not connected to your local cloud, local labs IP. So it's controlled so that your dot is not directly connected to your network. Yeah, and so when you combine all of these three things, that's what the LA is. The MIB itself is just a passive board. There are absolutely no active components on it. So if you build enough of them, these are really cheap. So you just have to buy the LA, Uh, and then the MIBs are to adapt whatever your particular boards are. The MIBs are actually extremely cheap.
Quick question. So in Remy's example of the custom hardware setup, you could have multiple Raspberry Pis connected to one host. Is there a plan to be stackable so you can put multiple boards on a single LAA instance?
No, on purpose, it's a one-to-one design. So you have one appliance with one DUT. The reason for that is that we found multiple issues. And for example, if you have USB issues, if the hub crashes for some reason, then all the DUTs will crash. So you will have fake results, wrong results, just because one DUT messed up with all the other DUTs. And there is also issues with some DUTs that have non-Unix serials. So you cannot. You have to rely on the USB path, which is really not really.
Yeah, and it's also if the worker itself, something fails on the worker, then you have 10 DUTs going down. Just
Okay, thank you.
Make it more atomic. So I'll just go through a few different type of MIBs we have. So this is the RPi for BMIB, the one that we have here at the demo. So in this setup, you don't need any cables. If you want to boot over serial directly, you can send the kernel over serial. That way, you don't need anything. Otherwise, you can either add like a network interface where you boot on an SD card, so you just need one cable, or we do have emulated USB storage, so you can just load an image file without writing it to anything, and then it will just boot on the Raspberry Pi. The second example is the 14C. This is an interesting one. It has a muxed fastboot USB port with the rest of the USB ports. So if you're doing any sort of USB testing and you need to turn off or like detach the fastboot cable, you can just turn off the ports. All of these ports are switchable. The port, the Type-C port at the end is actually PD compliant, and that helps a lot with boards like the RB3 and the RB5 that are actually expecting a phone charger or something like that connected. And we've had issues triggering fast boot properly on those hardware. So all of that's resolved there. This is the KV260. We'll have this demo on Demo Friday, but this is a situation where everything's on a fly lead. There's no connection on the DUT itself that we can adapt to the standard header. So we just create a MIB that has everything broken out. And one of the features is the KV260 requires a boot mode button to be pressed physically to get it into like a flashing mode. And so we have a couple of what we are calling virtual buttons. These are just solid-state relays. So they work fine. So talking about solid-state relays, everything on that board is solid-state. There are no physical relays to fail. All the power is done over MOSFETs. So we have a lot of way to collect data, including thermal sensors for the DUT, power sensors, and I think that's all about sensors we have. Yeah, all right. And then we can switch and power the DUTs over 1.8, 3.3, 5 volt, or 12 volt. We can switch the I/O voltage just with a passive jumper on the MIB, and so you can support 1.8 volt or 3.3 volt I/Os. And so because, again, everything's standardized, the reproducibility is the exact same. We are running all the DUTs in the exact same hardware using the exact same serial setup, exact same USB setup. So we can just reproduce issues. And then, you want to talk about fleet management a bit?
Yeah, and so the appliance is a full Lava worker, so it's an ARM. It's an ARM machine. And so we have a fleet management software that will handle all the software on it. So you don't have to care about the software. We are deploying automatically remote update to it. Also, because it's connected to a fleet management, you just interact with the fleet management to configure your appliance. So you will see a list of all your appliances, and you can decide which one will be connected to which instance. it will automatically configure the appliance for you. As I shown in the demo, you just set the device type that you have, and it will configure your Lava instance and your Lava worker in it automatically for you. And we have other features like testing your hardware with the latest version of Lava coming too. That will be useful for some people too. So it's a work of many people. So we try to list all the people that work with the appliance and help us to do that. So thanks a lot to all these people. That's really a group work, not only Saj and myself. It's all the group that work on it and many people in Linaro. We made it on purpose to be not too long. So if you have any questions, please ask a question that you have. And a microphone is here. Yeah.
Yeah, I could see there is a USB-C type port on that. So probably, is it possible to connect a device like Pixels or like phones, and how the power cycle happens on that? And it's on a Wi-Fi only mode, right? So how do we go about it?
Take this off.
Yeah, so the Type-C is PD compatible. You can plug in a phone, it'll be happy. But for complexity reasons, it's only 5 volt, 3 amp PD, so the base variant of it. But if you want like a full PD setup, then it's better to do it on the MIB from the 12 volt rail. So it can, but it's not recommended for phones that will draw too much power.
Yeah, and just for what it's worth, we are planning on taking advantage of this. We're going to have to design a special MIB board for handsets, but the idea is we're going to have them within the lab by the end of the year.
So for the phone MIB, so the mechanical interface board, the white one that you have here, we are working on a setup where you will have ways to press the button. So you will be able to test physical production-grade device phones, not only dev boards. So you will need ways to press buttons and control that, but that's planned.
Sorry for asking so many questions. This is really neat. I like it. Now, I have a special board, and I want to use this on here, and it needs special tools on the operating system, like a JTAG or something like that. How would I go about doing something like this, since you guys manage all the software?
Yeah, we have the same issues with some board that we have where you need a specific software. You can just install it on the fly inside the Docker container. Okay. If it's running inside on ARM64 inside the running Docker container, would be fine.
So I could put external hardware like a JTAG on this
yes.
and then control.
Yeah.
Okay, great.
We'll need some customization in the device support, but that's possible, yes.
You can like build, if the JTAG on the host side is USB, the SIP connector has USB, so you can literally build the JTAG itself on the PCB and just have smaller fly leads.
Yeah, I guess I was kind of just wondering like what the process would be. So like I send the patches to Lava to enable what I need, and then the Lava upgrade comes down, or because like I'm just wondering if I install software in there, will it mess up the update as you guys manage the software?
No, you are able to customize the Docker file that is used.
It runs on the board.
Inside.
Okay, got it.
So you can customize the way you want, yes. But for the process, if you want to use the appliance with a device which is not supported right now by Lava, is yes to put the support in Lava, because you know how to do that, yeah. Tyler. And then we can upgrade the device to the Lava version that you need, and it will work. Questions?
Yeah, I was wondering, quite often when you test things, if things go wrong, can you actually also log in remotely to the device under test using some virtual serial through that to poke around post-test and things?
So we have an opt-in feature which is remotely accessing the appliance, and from that you can do whatever you want.
Excellent. And just one more, larger devices such as Juno and N1 SDP, you support those?
Yeah. So for devices that absolutely have no way of fitting on, we have Flylead, and that just breaks out everything you need.
Sure.
But also, as Saj said, we have flyleads for devices that are not currently supported. It's a generical interface. But you also can design a PCB, a MIB that will match exactly your needs. That's also a way to go if you have a lot of Junos that you want to automate, for example. That since going for your custom MIBs, which is not really expensive to make, is a good option, yes. Really, the idea is that we have a standard board, which is the one on the below, the green one. And what is on top, the MIB, the mechanical interface, is a custom interaction between the standard one and your DUT.
Yeah, I mean, the plan was to just eliminate all variables in terms of PDUs used, because people use different kind of PDUs, people use different kind of USB hubs, and that ends up getting messy and difficult to control. So,
if you can pass the microphone, please.
I think somebody asked about it already, but I didn't hear an answer. What about Wi-Fi? If you have a device that doesn't have Ethernet but only Wi-Fi?
That's a good question. We don't have devices, but how do you interact with the device over USB?
so
Yeah.
What do you want to do with your Wi-Fi? Testing the Wi-Fi connection?
Well, you would need to boot over USB. I mean, load Linux over USB instead of over Ethernet,
so
and then indeed test the Wi-Fi as well.
Most phones are booted over USB, and then they don't have Ethernet, so you don't need Ethernet. It's not mandatory. It depends on the way you boot the device. For the Raspberry Pi, we boot over Ethernet because it's reliable and does not wear the device, but it's not mandatory. You can boot over. You have other ways to boot it.
Does that have a Wi-Fi chip in the LA?
no.
No, it doesn't. Okay.
And it
But if it did, you'd have a host AP.
Yes.
And then you could have
Yeah.
an AP for each one.
And if you want to do Wi-Fi testing, you can just plug a Wi-Fi over a USB Wi-Fi dongle and then configure it and use it. That will be an option, yes. We are close to the end of the session. Any last question? No. We will be at the Demo Friday showcasing the LA with a Raspberry Pi, the LA with a KV260. So please come and visit us. We'll be happy to see you. Thanks a lot.